Hello. So last time we see or we introduce the concept of binary numbers. It's just a numbering system, just like decimal, the ones that we used to use. Okay, and we see how to convert, like this example, how to convert binary numbers into decimal. It's their decimal equivalent. Now the turn is how to you do the opposite, how to convert decimal number like 53 into binary numbers. So let's have examples here. So conversion from decimal into binary. Okay, good. So basically we have two algorithms here. If the number is decimal, I'm sorry, if the number is integer, we have some algorithm to follow to convert it into binary. But if the number has, or if the number is just a fraction, we have another algorithm. If you have a number that has integer part and the fractional part, real numbers I mean, then you will do both algorithms to convert the decimal part, I'm sorry, the integer part, and then the fractional part with another algorithm. Here, let's start by a simple, algorithm, the simpler algorithm, which is to divide to convert the integer decimal numbers, like 53. So let's do the same examples we did, but in an opposite way. So we see previously how to convert the decimal equivalent, the binary equivalent of 53, 110101. Now we will start by 53, and we should reach the same result. So this is 53. And the algorithm here depend on the divisions by 2. So in each step of the algorithm, we will divide some number by 2. And the start here is our number that we want to convert. Any division result in two things: the quotient and the remainder of the division operation. Okay, 53 divided by 2. We know that 52 divided by 2 will give us 26. How about 53? 53 is an odd number. So there will be a remainder. So the quotient here is 26, because 26 multiplied by 2 will give you 52. So there is a remainder of 1. And this one will go to the remainder. And before we continue, I want you guys to look at the remainder here, and try to guess which one the remainder or the quotient will be our, binary equivalent for 53. Then we take the quotient, 26, and divide again by 2. As I said, each step will divide by 2. And in each step, we just divide the quotient. So 26 by 2 is 13, and the remainder is 0. Then we take the 13, divide by 2. This will give us 6, because 6 times 2 is 12. Then there is a remainder of 1. Then 6 divided by 2. This will give us 3, a remainder of 0. 3 divided by 2 will give us 1, and a remainder of 1. Then 1 divided by 2 will give us a quotient of 0 and a remainder of 1. Maybe you are not convinced with this last step, okay, how we divide the 1 by 2 basically, okay. So just before I explain more about it, just to convince you, let's now look at the quotient and the remainder of this operation and see which one will be our conversion. Basically, it's a remainder, because as you see here, the remainders are always 0 or 1 in each operation, right? So basically, this should be the conversion. So always the remainder is our conversion. Good. Now, should I write this number as 101011? I mean, from top to bottom, or write it as 1101? 0, 1, 0, 1. I mean from bottom to up. That's a very, important question because these are two different numbers. You may say, okay, let's convert back to decimal each one. I mean, apply the same steps that we did here, okay, to know which one is 53, okay? So basically, instead of doing that each time, so the rule is we have what's called the most significant digit and least significant digit in each number. So let's go back to our decimal number here, this 7,392. So basically, the most significant, we have here 7,000. So the most significant digit is a 7 because it represents 7,000. And the least significant digit is a 2, least significant, because this just represents 2 units. So we said that the 7 is 7,390, 9 tens is in 2 units. Okay, so we have also the same concept here in binary numbers. We have also significant digits and most significant digits and least significant digits. So for example here, this is the most significant digit, this is the least significant digit. But in binary numbers, we don't use the word digit, we use the word bit. So in binary numbers, this is called most significant bit, this is least significant bit. And just forget about the word digit. Although we know that, yeah, each number in a big number is just a digit, but we usually call it bit. So basically the rule here is this is the least significant bit, this is the most significant bit. So this number is wrong, and this is basically the right answer. This is the correct answer. This is basically 53 in decimal, represented as 110101 in binary. Okay, you can check here. We have already the example. So it is 110101 here. Yes, 110101. So we are correct. Now, you may not be convinced with this last step here. Okay, if you are not convinced, then follow me on that. So basically, we learned that a number like 4.5, so this is just an illustration, okay, can be written as 9 divided by 2. That's good, which is 4.5, right? So we can write this 9 by 2 or 4.5 as 4.5, just like what we say it, 4.5. Okay, good. Now if you have this 4.5, okay, let's analyze this number here. So this is basically a quotient, and this is basically the remainder. So 9 by 2 will give us a quotient of 4 and a remainder of 1. Okay, good. Let's take another example, like 3 by 2. So 3 by 2, okay, has a quotient of 1 and the remainder of 1. And actually, we did this here. Okay. Can we write it in that way? Yes, we can. It is 1 and 1 over 2. Can we convert it back? Yes. How we now convert this back into this number here? So let's start by 4.5. So we do the following. We multiply by the denominator by the quotient here. So 2 by 4, and we add 1, which is already in the numerator, and divided by 2. So this will give us 8 plus 1 over 2, which is 9 by 2. Good. How we convert that one into originally 3 over 2, so 1.5. It's basically you keep the denominator, and you multiply 2 by 1, this by this, plus 1. This will give us 2 plus 1, which is 3 over 2. Now, what I am saying here is that 1 over 2 is actually 0 and a half. Like 1 and a half, 4 and a half, right? So did this already really equal to this? Yes, let's convert. Let's do the same conversion here. So this is basically, we keep the 2, then we multiply 2 by 0, and we add the 1. This will give us 0 plus 1 over 2, which is 1 over 2. So this is basically the quotient, and this is basically the remainder. This is for you, for whom of you that didn't, understand it well. Now let's take another example, like converting. Now let's take another example. So example 2, let's convert 41 into its binary equivalent. Okay, so we have 41. Okay, and we have the quotient and the remainder. 41 by 2 is 20, and a remainder of 1. Again, why? Because 2 times 20 is 40, and we will have 1 as a carry, or a remainder, I'm sorry. Then we have 20 by 2. This will give us 10, and a remainder of 0. Then 10 by 2. This will give us 5, and a remainder of 0. 5 by 2. This will give us 2, and a remainder of 1. Then 2 by 2, this will give us 1, a remainder of 0. Then 1 finally by 2, this will give us a quotient of 0 and a remainder of 1. Once you reach a quotient of 0, we just stop, because 0 again divided by anything, 2 or 8 or whatever, will give us 0. Okay, so this is again the least significant bit. This is the most significant bit. So 41 in decimal is actually, we go in that way, 101,001. This is the equivalent of 41 in binary. Now, can we verify that? Yes, you can convert it back, and that's easy as well. So this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5. So 32, which is 2 to the power of 5, plus 8, which is 2 to the power of 3, plus 1, which is 2 to the power of 1. 32 plus 8 is just 40. 40 and 1 is 41. Okay, guys. So this is basically the conversion from decimal to binary, and from and how to verify your answer. Okay, so see you in the next video. Bye-bye.